This study tried to understand how degradation of Webhub Alpha protein is controlled. So Webhub Alpha is the transcriptional repressor that functions as a negative feedback onto the major clock protein clock and BMAL, which ultimately drives activity and physiology of an animal in a circadian manner. Most proteins in the cells are degraded by the ubiquitin proteasome system. I just want to point out the most important step is that E3 ubiquitin ligase will attach a ubiquitin molecule onto the lysine residue of the substrate protein to be degraded. So at the beginning of the study, we tried to determine whether some lysines on the Webhub Alpha protein are important for ubiquitination and also degradation. So turned out we had to change all 20 lysines to arginine, and we still saw some surprising results, which is shown here. In this experiment, Wildtype or R20 are transfected along with HA tag ubiquitin expression vector. So when Webhub Alpha was immunoprecipitated and then plot with anti-HA antibody, you can see a ladder of bands here. They are all larger than the size of the Webhub Alpha, so they represent ubiquitinated Webhub Alpha. However, these bands are also found in the R20, suggesting that even without any lysines, Webhub Alpha can still be ubiquitinated efficiently. So it turned out in the literature there are a dozen or so proteins. They are ubiquitinated at the N-terminus using the free amino group of the methionine. So I therefore made small deletion in the N-terminus of Webhub Alpha to see whether it will affect degradation. So these two mutants deleting 8 or 16 amino acids are transfected along with the Webhub Alpha wild type. And this is the time course of degradation. You can see this mutant degrade much faster, and this mutant degrade much slower. That means that it's more stable. This is interesting because it suggests that there is important control at the N-terminus, which allow a switch of the protein to become highly unstable, perhaps at the right time of the day. This experiment tries to look at where on Webhub Alpha protein the ubiquitin ligase SP-SP4 will bind to. Because of time, we just go through this data quickly. So we immunoprecipitate Webhub Alpha, the wild type, or these two different mutants, which delete about 25 amino acids from the N-terminus. So you can see that when you plot with anti-MYC antibody, you're looking at whether SP-SP4 can be brought down by Webhub Alpha antibody. So wild type, you can bring down SP-SP4, and then this mutant, you can also bring down SP-SP4. However, in this mutant, D2 to 25, you cannot bring down SP-SP4. So that means SP-SP4 bind to this region, which is same as the switch that we just described in the last slide. So a quick conclusion slide here. So now we may have data to propose a model to help us explain how Webhub Alpha is only found in the cells between 6 and 9 hours after light is turned on, and it quickly disappears from the cells. Perhaps there's time to work where the protein function is needed. It's in a stable conformation. And when it's time to stop, that means the protein is no longer needed. There's a conformational change, and maybe now SP-SP4 can bind to the 16 amino acid, which we identify as the binding site. And ubiquitination may occur at the N-terminus now. Data I didn't have time to show, maybe phosphorylation of tyrosine, and then dephosphorylation of some serines in the same region. And finally, the protein can enter the 26S proteasome and get degraded. And perhaps even more exciting is, in the future, we are now able to make some degradation switch mutant and check what would happen to the protein, whether it become more stable and just last longer, or perhaps even more interesting, the protein profile of degradation is the same, but the time has shifted, and how it will affect the activity and the physiology of an animal. So finally, people I'd like to thank, and also certainly the RCMI pilot project program. Thank you very much. Question and suggestion, please email me.